Now let's talk about distances and lengths, which of course is one of the most fundamental concepts in geometry. If we have 2 points in space, how do we calculate the distance between these? So we want a formula in terms of the x, y, and z coordinates of these points. Let's start by going back to the 2D case. Here, by drawing a right-angle triangle, the Pythagorean theorem tells us that the distance squared is x2 minus x1 squared plus y2 minus y1 squared, or if you prefer, d equals square root x2 minus x1 squared plus y2 minus y1 squared. To tackle the problem in 3 dimensions, we'll introduce a third point so that we're only changing 2 of the coordinates at a time. So if we call these points A and B, these have coordinates like so, then this new point, which I'll call C, has the same x and y coordinates as B, but the same z coordinate as A. Now we look at the plane passing through these 3 points. So the Pythagorean theorem applied in this 2D plane tells us that the distance squared from A to B is distance squared from A to C plus distance squared from C to B. And that last distance is just z2 minus z1 since B and C have the same x and y coordinates. Now to get the distance from A to C, we look at the plane that goes through A and C and is parallel to the xy plane. Applying the Pythagorean theorem in this plane gives distance squared from A to C is x2 minus x1 squared plus y2 minus y1 squared, since they have the same z coordinate. Putting this together, we get distance squared from A to B equals x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. One application of this formula is it lets us write down the equations for spheres. So by definition, the sphere of radius r centered at a point P consists of all points of distance r from that point. So if P has coordinates x0, y0, z0, then by the formula we just worked out, this translates to x minus x0 squared plus etc. with all the other coordinates equals r squared. In particular, the equation for a sphere centered at the origin is x squared plus y squared plus z squared equals r squared, and the equation for the unit sphere is x squared plus y squared plus z squared equals 1. So here already is an example of the usefulness of different coordinate systems. The first equation looks a lot more complicated than the second one, but if we just move our coordinate system so that the origin is at the center of this sphere, then we can treat any sphere as centered at the origin. And similarly, we could adjust our units so that the radius is 1.